Hi, I'm Jay from Real Street Performance. Today we're going to talk about different types of head gaskets that you can use on your forced inducted vehicle. In this video, we'll be talking about composite head gaskets, multi-layer steel head gaskets, copper head gaskets, and the fire ring approach. The head gasket plays a critical role in the engine. It seals the combustion in the cylinders, the coolant in the coolant passages, allows pressurized oil to flow up into the cylinder head to lubricate the valve train, and offers oil drain back to get that oil back into the pan. Head gaskets can come in different thicknesses, so you can make a compression ratio change if you'd like, or you may need a different bore size head gasket if you've drastically changed the bore size of your engine. For the sake of this video, we're going to talk about some different approaches that you may find in the performance industry when it comes to head gasket sealing. The first head gasket we're going to talk about is the composite head gasket. Composite head gaskets are nothing new, and they served the automobile industry well into the mid-1990s. They're relatively inexpensive and don't require any special machining to make them work. They also work well with less than ideal machine work. Keep in mind, 50 years ago, we did not have the precision machines that we have access to today. As far as its downsides, the composite head gasket is its own blessing and a curse. If you think about early turbocharged vehicles like a DSM, it didn't take much of a tuning error to blow a head gasket. Composite head gaskets are like low amperage fuses. It doesn't take much to make one pop. And with that being said, the likelihood of damaging other engine parts when you blow a head gasket is relatively low because the head gasket is the fuse. The next head gasket we'll talk about is the multi-layer steel head gasket, or MLS. As engine machine work improved, MLS gaskets gained popularity. They require a perfectly flat deck with a relatively slick finish in order to seal. As long as the deck of the block and the deck of the cylinder head keep shape well, the MLS gasket is very hard to blow. Now, there are different types of multi-layer steel gaskets. Some of them don't have any embossing around the cylinder to aid in combustion sealing. And with those types of gaskets, you'll see people use copper O-rings in the block or in the head to compress around the cylinder to help create a seal. Then there's what they call stopper gaskets, which have a folded rolled lip around the combustion area of the gasket, making it quite a bit tougher than the non-embossed style. These don't require any type of O-ring or anything like that to make them highly effective. The downside to an MLS gasket is that if you don't have perfect machine work where the deck of the block and the deck of the cylinder head is perfectly flat with the correct surface finish, they do not seal well. The second downside to an MLS gasket is they only have about 3 to 4 thousandths of spring memory to them. So if you're dealing with an engine that distorts under load, once you uncover that gasket, you're going to have a leak. So it's best used on an engine that has a lot of integrity so the parts don't move around during use. The third and final downside to an MLS gasket, in my opinion, is because it's a multi-layer steel gasket. When they blow, they generally do it with other part damage. So you're dealing with damage to the cylinder head or the block, because when you get the engine mistuned enough that it's lean enough or hot enough that it starts to torch, it doesn't just get the gasket, it often gets the surrounding metal components. The third option is a copper head gasket. Copper head gaskets have been used for decades by race teams and are still the first choice of many racers. Using a copper head gasket requires more machining because you need to have a receiver groove cut in the block and a receiver groove cut in the head, and then you're going to put a stainless steel wire in one or the other, and then the gasket is displaced into the receiver groove that does not have the wire ring in it. This creates an interlocking seal that holds combustion very well. One of the benefits with the copper head gasket is with its soft, malleable material, it can offer the engine components some room to move around. For example, when you're dealing with a high boost or high stress situation, the deck of the block or the deck of the cylinder head can distort and try to uncover the head gasket, allowing the combustion to leak. But with the interlocking design of the installation with a copper head gasket, you can have some movement on the deck of the block or on the deck of the cylinder head and still maintain a combustion seal. Also, because it's a soft material, it will often push the gasket before it blows the gasket. And with a coolant pressure sensor, you can monitor this and know when it's time to service the head gasket. For example, when we were using a copper head gasket on our Supra, I could just watch the coolant pressure, and after a certain number of runs, or if I had made a mistake, I would see that coolant pressure elevate, and I could just take the engine apart, service the gasket, and put it back together without any catastrophic problems. Another benefit with the copper head gasket is they're highly customizable. So if you're dealing with an odd engine or you need an odd thickness, you can often have it in a much shorter lead time than you would ordering a custom multi-layer steel gasket. The next benefit of a copper head gasket is copper is an excellent conductor of heat. The thought process behind this is that you'll have a more even temperature along the sealing surface of the engine. There are people that maintain that when the cylinder is in a runaway condition, a steel gasket can have localized heating that promotes torching. Now on to the downsides of the copper head gasket. Due to the machine work involved, you want to be dealing with a reputable machine shop with a long-running history of success with copper head gasket systems. Remember, it's the depth of the receiver groove and the protrusion of the stainless wire that create the interlocking system that make copper head gaskets so effective. If this machine work isn't done correctly and you have the wrong tolerances, you'll have a mess on your hands that's hard to correct. Another downside with copper head gaskets is the sealing of coolant or oil on a wet deck engine. Copper head gaskets are best suited for dry deck engines as their specialty is sealing combustion. If you're using the copper head gasket on a wet deck engine, you're going to have to apply a secondary sealant in order to get the engine to not leak oil into the coolant into the oil, or oil and coolant leaking externally out of the engine. This will require either a spray on or smeared on sealant, and it's often a messy procedure that doesn't have good long-term results. The last downside with the copper head gasket is you're forced to retorque the cylinder head. During the first heat cycle, the copper relaxes, reducing the clamping force applied by the fasteners. In order to correct this, you have to go back through one by one, loosening each fastener and torquing it back to spec in order to create a competent seal. This is a bit of a hassle on some engines because you're required to take the camshafts out just to get to the cylinder head fasteners. The last gasket we're going to talk about today is a fire ring system. The fire ring system has been used in the diesel community for quite some time, and it's made its way into the gas racing industry in the past few years. The fire ring system uses a precision machined copper nickel alloy ring that's received in the block that creates a nearly indestructible combustion seal. The fire ring gasket system looks to be the toughest commercially available gasket system on the market today. With its robust design, it can seal combustion in even the most extreme racing engines. Now let's talk about the downsides of the fire ring gasket system. Due to the precision machining, it's the most expensive gasket system we've talked about today. And if you're using a wet deck engine, it still requires the use of a copper head gasket to seal any coolant or oil that are passing through the deck. So you still have the same sealing obstacles on that side of the gasket, but the combustion is handled very well. Unlike a traditional head gasket, the fire ring is a solid device. So when you bolt the cylinder head to the engine, you're just talking about forcing those objects together to create a seal. What we found is that the fire ring needed to be 0.03 of an inch taller than the head gasket in order to create a good combustion seal without damaging the cylinder head. Additionally, the fire ring gasket system is so tough that if you have a mistake, it's going to destroy some parts. If you've seen the videos of those diesel engines that are separating above the crankshaft mains and it just blows the whole top of the engine block off, that's when you've got a really, really good head gasket. I've torn engines up with a fire ring on them before too, and the fire rings look pretty good and everything else is junk. So there is no fuse. You've removed the fuse and you now have a situation where it's either all good or all bad. Thanks for watching this video, and please remember that picking the right gasket system for your goals should be done early in the planning process, as different gasket systems require different machining. If you'd like to geek out more on this subject, early turbocharged Formula One had some really neat gasket systems, and there were even some Indy cars that didn't have head gaskets at all. Thanks, and if you have any questions, feel free to reach out.